Okay, so looks like you've given us quite a stack of articles on nested loops this time. I
Yeah.
guess we're really going deep into coding with this one.
Absolutely. And
It's a pretty fundamental concept.
yeah.
But, there's a lot more to nested loops than it might seem like at first.
Oh, yeah, definitely. I mean, you might think, oh, they're just loops within loops.
Right.
But to really understand them,
Mm,
to understand how they work, how to optimize them, how to use them for, real problems.
right.
That's what really takes you from just a casual coder
Yeah.
to, someone who really knows algorithms.
So no pressure then.
Yeah.
For those listening who maybe you're thinking, wait, what's a nested loop again?
Right.
Can we start with just a really quick definition?
Absolutely.
Huh.
You can think of it like you're baking, trays of cookies.
Okay.
So the outer loop is like deciding how many trays of cookies you're going to bake.
Okay.
And the inner loop is like baking each individual cookie on that tray.
Right.
So you're not just baking one cookie and then moving on to the next tray, right? You're baking all the cookies on one tray and then you move on to the next one.
Got it.
So that's essentially what a nested loop does. The inner loop runs completely for each step of the outer loop.
Okay. That analogy makes sense, but we're not just, making cookies here.
Right.
Why are nested loops so essential in programming?
Yeah.
What kind of problems can we solve with this, cookie baking logic?
Well, one of the articles you gave me was from Algo Academy, and they list a few really interesting applications.
Okay.
For example, you can work with data that's organized like in a grid,
Okay.
like a spreadsheet or an image.
Yeah.
And nested loops make that so much easier because
Yeah.
you can systematically access each cell or each pixel using two loops,
Got it.
one for the rows and one for the columns.
Right. So it's kind of like a super efficient way to go through like a maze of data
Exactly.
and like visit each cell precisely and do something.
Exactly.
I can see how that would be incredibly useful.
Yeah, definitely. And another really interesting use case is for finding prime numbers.
Oh.
There's this classic algorithm called the sieve of Eratosthenes,
Okay.
which uses nested loops to efficiently find all of the prime numbers
Okay.
up to a certain limit.
Prime numbers. That sounds a lot more complex than our cookie analogy.
Yeah.
Can you maybe break that down a little bit further?
Yeah, so imagine you have a list of numbers.
Okay.
The algorithm starts by saying, okay, all of these numbers are prime.
Okay.
And then it uses nested loops to go through the list.
Okay.
And for each number, it marks all the multiples of that number as not prime.
Okay.
And what you're left with is just the prime numbers.
So the outer loop picks a number, and then the inner loop goes through the list marking all the multiples.
Right.
It's a very organized elimination process.
Exactly. And that's what's so powerful about nested loops.
Yeah.
They let you do these repetitive actions with incredible precision and efficiency.
So we've seen they can handle data, they can make patterns,
Right.
they can even find prime numbers.
Yeah.
Really amazing how much you can do with just two loops. But I have to say, the way they execute can still feel a little bit mysterious.
Right.
So can we maybe go through that flow of execution, like step by step,
Absolutely.
using a simple example?
Let's look at a very basic example from the Algo Academy article.
Okay.
It's a nested loop that prints a simple pattern of numbers.
Okay.
And it looks like this.
Okay.
For I in range 3.
Okay.
That's our outer loop.
Right.
For j in range 2.
Okay.
That's our inner loop.
Got it.
And then we have print ij.
Okay. So two for loops, one nested inside the other. What's happening here?
So the outer loop,
Yeah.
which is controlled by the variable I,
Okay.
is going to run 3 times.
Okay.
And for each of those iterations, the inner loop, which is controlled by j,
Right.
is going to run twice.
Okay.
And inside the inner loop, we're just printing the values of I and j.
So it's like those Russian nesting dolls.
Exactly.
The outer loop sets the stage, and then for each step, the inner loop does its thing.
Yeah, exactly. And let's really trace through what's happening step by step. So in the first step of the outer loop, I is 0.
Okay.
And then the inner loop runs twice,
Okay.
with j taking the values of 0 and 1.
Okay.
So the output's going to be 0, 0.
Right.
And then 0, 1.
Got it. So the inner loop completes its whole cycle
Yes.
before the outer loop moves on to its next step.
Exactly.
All right.
And then the outer loop goes to its second step,
Okay.
where I is 1.
Right.
And then the inner loop runs again,
Okay.
printing 1, 0, and 1, 1.
Okay.
And then finally the outer loop goes to its third step,
Right.
and we get 2, 0, and 2, 1 printed.
Okay. So by the time both loops are done running,
Right?
we have this neat little sequence of numbers.
Yeah.
all thanks to the, like, precise interplay between the outer and inner loop.
Exactly.
It's starting to click now, seeing how these loops work together.
Crazy.
But while nested loops are super versatile,
Right.
they do come with some potential pitfalls, too.
Yes, definitely.
That even experienced programmers can fall into. Oh, I bet. So let's talk about those.
Yeah.
Because I'd rather learn from someone else's mistake than go through the nightmare of debugging myself.
Right.
So what are some things that can trip us up when we're working with nested loops?
One of the most common ones is creating an infinite loop,
Okay.
where your loop never becomes false and it runs forever.
That sounds like a recipe for disaster.
Yeah, it can be.
So how do we avoid accidentally creating one of those runaway loops?
It all comes down to your loop conditions.
Okay.
So you need to make sure that the variables that are involved in that condition
Right.
are being changed within the loop
Okay.
in a way that will eventually make the condition false.
Okay.
Otherwise, they'll just keep running forever.
So it's like setting a timer on the oven. You don't want those cookies baking forever.
Exactly.
You need to make sure the loop eventually has a stopping point.
Exactly.
What other pitfalls should we watch out for?
Another really common one is what we call off by one errors. And these happen when you miscalculate the loop boundaries, usually because you're confused about whether to use a less than or equal to sign.
Oh, right. So one tiny little mistake with those comparison operators
Yeah,
can lead to all sorts of unexpected results.
exactly. It's like trying to access data that's outside of the bounds of an array.
Right. Like reaching for a cookie that's not there.
Exactly.
Yeah.
And those errors can make your program crash or produce the wrong output.
Right.
So you have to be really careful when you're setting up those loop conditions.
Okay, so we've covered what nested loops are.
Right.
We've talked about their applications and some common pitfalls.
Yeah.
But now I'm really curious to see them in action
Yeah.
with some more interesting examples.
Okay.
So how about we dive into some code snippets after a quick break?
Sounds good to me. We can take a look at some of the examples from the Algo Academy article,
Okay.
and we can really see how those nested loops work to create those patterns and solve those complex problems we were talking about.
Awesome. Let's do it.
Okay?
All right, I'm excited to see these nested loops in action. Before the break, we were talking about how they can be used for things like finding prime numbers, working with 2D data, and even generating patterns.
Yeah.
Can we jump into a real code example now?
Absolutely. One of the articles you shared from Algo Academy has some great examples that are perfect for this. Let's start with something classic like a multiplication table.
Yeah, those rows and columns of numbers, I feel like I've always just taken them for granted. But now I'm really curious to see how the code actually generates that table.
Okay, so here's the code from Algo Academy
Okay.
for I in range 111,
Okay.
for J in range 111.
Okay.
Print I, J, and T.
Okay.
Okay.
2 for loops nested again. So the outer loop controlled by I is going from 1 to 10.
Right.
That makes sense. We want a 10 by 10 multiplication table. What's the inner loop doing?
The inner loop, which is controlled by J, also goes from 1 to 10. And for each value of I, the inner loop runs through all the values of J.
Right.
It calculates the product of I and J and then prints it.
Okay.
The NT part is just making sure that the numbers are separated by tabs.
Right.
And the print after the inner loop creates a new line
Got it.
for each row of the table.
So if I is 1, the inner loop goes through all the values of J from 1 to 10,
Right.
printing 1, 2, 3, all the way to 10.
Exactly.
Then I becomes 2, and the inner loop repeats, printing 2, 4, 6, and so on.
Yeah.
That's how we get all the multiples in the table.
Exactly. It's like this little machine that systematically generates each entry in the table, one row at a time.
That's really neat. I never realized how simple but powerful this concept is. Let's try another visual example. Algo Academy also shows how to create geometric patterns using nested loops, like that right-angled triangle made of asterisks.
Oh, yeah.
Can we take a loop at that?
Sure. Here's the code for that pattern. For I in range 1, 6.
Okay.
For J in range print end.
Okay.
Print.
Okay, so the outer loop controls the number of rows, again going from 1 to 5. What's different about the inner loop this time?
So this time the inner loop runs from 0 up to the current value of I.
Okay.
So in the first row, when I is 1, the inner loop only runs once
Okay.
and prints a single asterisk.
Right.
In the second row, when I is 2, the inner loop runs twice and prints 2 asterisks.
I see. So that's how it creates that triangular shape.
Yeah.
The number of asterisks in each row
Yeah.
is determined by the row number itself.
Exactly. And inside the inner loop, we're just printing an asterisk and using end to keep them all in the same line.
Okay.
And then the print After the inner loop, make sure each row is printed on a new line.
This is really cool. I can see how you could get creative with these patterns just by tweaking the loop conditions and what you're printing inside.
Oh, absolutely.
Mm.
And a lot of times you'll find that the most elegant solutions to these seemingly complex problems involve using nested loops in a clever way. Remember that prime number algorithm we talked about earlier?
Yeah, the sieve of Eratosthenes.
It's exactly.
Yeah.
That's a great example of how nested loops can be used to create really efficient algorithms.
Yeah, we talked about the logic behind it, but can we actually see how that's implemented using nested loops?
Sure. Let's say we want to find all the prime numbers up to 100.
Okay.
Here's how you might do that in Python.
Okay.
N 100.
Okay.
True. N plus 1.
Okay.
P2.
Okay.
While. PAM.
Okay.
If
Primate.
true.
Right.
For I in range.
Okay.
PP N plus 1P.
Okay.
Primap false.
Okay.
P plus 1.
Okay.
Prime mep equals 1.
Okay.
Prime mep equals 1.
Okay.
False.
Fair.
Prime 1 plus 1. If prime mep.
Okay.
Prem P and boom.
Wow, that's a bit more involved than the previous examples, but I can still see the nested loop structure in there. Can you break down what's happening step by step?
Yeah. So first we're creating a list called prime to keep track of whether each number is prime or not.
Okay.
And we're starting by assuming that they're all prime.
Okay.
The outer while loop goes through all the possible prime numbers, starting from 2. And the inner for loop marks all the multiples of P as not prime.
So the outer loop is like our prime number generator,
Right.
and the inner loop is like eliminating the multiples.
Exactly.
I like how you used a Boolean list to keep track of the prime numbers. That's clever.
Yeah, it's a nice way to do it.
Very efficient.
And then after the loops are done, we just print out all the numbers whose corresponding value in the prime list is still true.
Okay.
Those are the prime numbers.
This is fantastic. It's amazing to see how something that seemed pretty abstract can be implemented so neatly with code. But I'm guessing that using nested loops like this can affect the efficiency of our code, especially when we're working with larger data sets.
You're absolutely right. Nested loops can be computationally expensive, so understanding how to optimize them is really important.
Okay, so let's talk about optimization. What are some strategies we can use to make our nested loops run faster and more efficiently?
One important concept to understand is what we call time complexity,
Okay.
which basically measures how the runtime of an algorithm increases as the input size grows.
Okay.
And for nested loops, the time complexity is often on the order of what we call big O of n squared.
Big O of n squared.
Yeah.
That sounds pretty technical. Can you explain it in a way that even I can understand?
So imagine you have a list of n items.
Okay.
A simple loop that goes through each item one by one has a time complexity of big O of n,
Okay.
meaning the runtime grows linearly with the input size.
Right.
But with nested loops,
Yeah.
for each item in the outer loop,
Right.
the inner loop has to go through all n items again.
Okay.
So that's n times n operations,
Okay.
which is why we call it big O of n squared.
So as the input size gets bigger, the runtime of those nested loops can really increase dramatically.
Yeah, exactly.
So making those loops more efficient is really important.
Right.
What are some things we can actually do to improve the efficiency of our nested loops?
Well, one simple technique is to move any calculations or operations that don't depend on the inner loop's variable outside of the inner loop.
Okay, so kind of like prepping all your ingredients before you start baking each batch of cookies,
Exactly.
instead of grabbing things one at a time during the baking process.
Exactly. That's a great analogy.
Makes sense. What else can we do to streamline those loops?
Another really helpful technique is to use what we call break and continue statements.
Okay.
So a break statement lets you exit a loop early if a certain condition is met.
Okay.
And that can save you some unnecessary iterations.
Right.
And a continue statement skips the rest of the code
Yeah.
in the current iteration
Okay.
and jumps to the next one,
Got it.
which can also help you avoid unnecessary calculations.
So it's all about being strategic
Yeah,
and finding those opportunities to skip steps and make the loop run faster.
exactly.
It's like we're code ninjas optimizing our way to victory.
That's the spirit.
So we've got break and continue. What else can we do?
Well, there are even more advanced techniques we could explore, like something called dynamic programming
Okay.
and recursion, which use nested loops to solve really complex problems in elegant and efficient ways. But those are topics for another deep dive, maybe.
I'm adding those to my list of things to explore. But for now, I think we've covered a lot of ground on nested loops. We've seen how versatile they are, we've talked about the pitfalls, and we've even learned some ways to optimize them. What else can we dive into with the time we have left?
Well, since you mentioned earlier that you're preparing for a technical interview,
Right.
maybe we could talk about how nested loops are used in those coding challenges
That's a great idea.
and give you some tips for tackling them.
I'm always a little nervous about those technical interviews.
Yeah.
So knowing how to handle nested loops with confidence would be a huge advantage.
Definitely.
What are some common scenarios where they might test your knowledge of nested loops?
One really common one is asking you to write code that generates specific patterns using nested loops.
Okay.
Kind of like the examples we just saw.
Oh, okay. So they might ask me to create a diamond shape or a pyramid using asterisk.
Exactly.
Right.
It's testing your understanding of how to control those loop iterations
Okay.
and manipulate the output.
That actually sounds kind of fun. What other kinds of questions might they ask?
They might also give you a problem that involves going through a 2D array
Yeah.
or a matrix
Okay.
and ask you to find a specific element, calculate a sum, or perform some kind of transformation on the data.
So like finding the largest number in a matrix or calculating the average of all the elements.
Exactly. Those are really common tasks.
Yeah, those are things I've come across in my own projects.
Right.
What are some key things to keep in mind when I'm trying to tackle these kinds of coding challenges?
One of the most important things is to explain your thought process out loud to the interviewer.
Okay.
So walk them through your code step by step.
Okay.
Don't be afraid to ask clarifying questions.
Right.
This shows that you can problem solve and that you can communicate clearly.
So it's not just about writing the code. It's also
No.
about explaining my reasoning and talking to the interviewer.
Exactly. It shows them how you think.
Okay, that makes sense. Any other tips for impressing those interviewers with my nested loop skills?
Another really important thing is to think about edge cases
Yeah.
and potential optimizations.
Okay.
So think about what might happen if the input is empty or if it contains unexpected values.
Right.
How would your code handle those situations?
Okay.
And also, can you think of any ways to make your solution more efficient,
Okay.
like reducing the number of iterations or using those break and continue statements strategically?
Those are all really good points. It's easy to get caught up in just making the code work,
Right.
but thinking about those edge cases and ways to optimize shows that I'm thinking critically and considering the bigger picture.
Exactly. And remember, practice makes perfect.
True.
The more you practice solving these kinds of coding challenges that involve nested loops,
Yeah.
the more comfortable and confident you'll become.
This has been so helpful.
I'm glad to hear that.
I feel much more prepared to face those technical interviews now.
Good.
Knowing that I can confidently handle those nested loop scenarios, we've covered so much today.
Yeah, we have.
From basic concepts to optimization techniques and even interview tips, I'm amazed by how versatile nested loops are.
Yeah, me too. They might seem simple at first, but once you master them, you can do so much with them.
Right.
They open up a whole world of possibilities in programming.
Absolutely. So to everyone listening, thanks for joining us on this deep dive into nested loops.
Yes. Thank you.
We hope you've learned something new and are feeling inspired to go out and write some awesome code.
Keep coding, everyone.
So we were just talking about those technical interviews and how nested loops are kind of a favorite topic for interviewers.
Yeah.
And it's making me think, are there any other areas where understanding nested loops is like especially valuable?
Oh, yeah, definitely. I mean, besides technical interviews, you'll find nested loops being used all over the place in programming, like in image processing,
Okay.
where you might need to work with individual pixels in a 2D image,
Right.
or in game development,
Okay.
where you can use nested loops to control how things move around in the game world.
Right. So anytime you're dealing with something that has that kind of grid or matrix structure,
Exactly.
nested loops are the tool to use.
Yep.
But I'm also thinking about the bigger picture here.
Yeah.
We've seen how nested loops are used in like specific algorithms, like the sieve of Eratosthenes for finding prime numbers.
Right.
Does mastering nested loops help us understand those more complex algorithmic concepts?
Absolutely. Nested loops are often the building blocks for more sophisticated algorithms and techniques,
Okay.
like dynamic programming,
Right.
which is a really powerful problem-solving approach.
Yeah.
It uses nested loops to break down complex problems into smaller overlapping subproblems.
Okay.
And by solving those subproblems just once and storing the solutions,
Okay.
dynamic programming algorithms can be incredibly efficient.
So it's like we have this toolbox full of nested loops,
Yeah.
and we can use them to build these intricate problem-solving machines.
Oh.
It's amazing how these simple concepts can be combined to create such powerful solutions.
Yeah, it really is.
And as we continue to learn and explore,
Right.
we'll discover that nested loops are just one piece of the puzzle.
Yeah, they're a fundamental concept,
Yeah.
but they connect to so many other areas of programming and algorithm design.
Right, like understanding how nested loops affect time complexity
Exactly.
is crucial for writing efficient code.
Yeah.
That was that big O of n squared
You-
thing,
Yeah.
which basically meant that the runtime of nested loops can really increase as the input size grows.
Right.
And that makes optimization so important.
Yes, definitely.
Are there any other optimization strategies that we haven't talked about yet?
One technique that can be really helpful when you're working with large data sets
Yeah.
is to think about using different data structures.
Okay.
So instead of using nested loops to search for a value in a list,
Right.
you might consider using a set or a dictionary,
Okay.
which can give you much faster lookup times.
So it's all about choosing the right tool for the job.
Exactly. Sometimes nested loops are the best way to go, but
Okay.
other times a different data structure or a different algorithm might be more efficient.
Right. It's been a really interesting journey into the world of nested loops.
it has.
We started with a simple analogy of baking cookies.
Yeah.
And now we're talking about advanced algorithms and data structures.
It's amazing how much depth there is to this concept.
I have to say, I'm feeling a lot more confident about my coding now,
That's great.
knowing that I have a good understanding of nested loops and how to use them. It's like
Thanks.
I've unlocked a new skill.
That's awesome. And remember, the learning never stops.
Right.
Keep experimenting, keep challenging yourself, and don't be afraid to dive into those more complex concepts.
Well said. To all our listeners, thanks for joining us on this deep dive into nested loops.
Thank you.
We hope you've learned some valuable insights and feel inspired to go write some amazing code.
Absolutely.
Until next time, keep coding and keep exploring.